running network, we clean everything for you. That is like one of the key concepts that we have when we build Zombienet. But also before, why we build Zombienet? And we build Zombienet because we have some friction related to how we test the network. Because integration tests are always complex, all right? It's always complex with the set up the configuration for a new network. There's all port management. You need to know when all the artifacts are ready to start your test. You need observability tools that allow you to know what happened in the network without interacting with the network. And it's also one of the key concepts that we don't want to leak in resources. We don't want like pod running over there or process that keep running and you don't manage that. So all this complexity exists in all integration tests, but in the cases of blockchain it's more difficult because there are many artifacts that you need to orchestrate to create the relay chain, for example, the parachain, register the parachain. So there's a lot of stuff going out there and it's really complex, and that's why we start the Zombienet project. But before we start the Zombienet project, internally in Parity, there was some other projects that we take some inspiration from them. And these are some of the projects that we research when we start the Zombienet project. One is Polkadot Launch. Maybe it's everyone knows Polkadot Launch is one of the tools that almost everyone, and also in the tutorial, it was like recommended to use to launch a network. Right now it's deprecated in favor of Zombienet. We have Simnet. It was an internal also project for running simulation networks in Parity. Parachain Launch is from the Web3 Foundation, also allow you to launch big network with parachains. And Polkadot Starship is another like isolated project. So we researched all these projects and we found different friction to resolve because everyone was great, but they had different friction. We talked with the people that use those projects and we collect the feedback in favor to see what are the friction that we want to resolve with this new project that we call Zombienet. And some of the friction that we found in the way that building Zombienet is that most of the tools that was currently available 1 year ago, because Zombienet started mostly around 1 year ago, maybe a little bit longer, is that configuration was not flexible. It was a JSON file in most of these projects. You had to set everything in a JSON file. It's not like really flexible. You need to, for example, set all the ports, and it was only running in local environment. So that is good for developers to run a network in your laptop, but it's not good for CI, for example. So it's not CI friendly. All this project doesn't have a test runner, so allow you to just spawn a network, and then you need to hook up with some runner or some test tool for starting testing this network. Another key aspect of that is that those projects was like a solo project and the maintenance was not good. So our idea is create a team internally in Parity that maintains Zombienet. So we take care of the tool, we take care of the feedback from the community, and we try to make the better tool for the community. And also, one of the key aspects is the scaling. We have, we see later in the presentation that we have one concept called providers that allow you to run Zombienet in different environments and scaling the network as you need. So after see all this friction, we set up the goals that we have for this project. So one of the first goals we set up is that should be easy to set up, right? Should be hassle-free setup. We allow right now to use TOML or JSON file configurations. So you can decide if you want to go with TOML or with JSON. It's okay by Zombienet, and we plan maybe to add more stuff there. We want to have nice defaults. We don't want to developers have to set everything. So we have some defaults that are logical for launching different networks. So for example, we manage the port. We have default for the relay chain binaries, for like parachain binaries and stuff like that. And we have a templating language allow you to just express the configuration dynamically, and we will see this later. Other goal that we want is we want to run this in a multiple environment. We don't want to run only locally. So when we think of multiple environment is like we want to run in containers. Right now we can use Podman, and you can use also Kubernetes, for example, for scaling the network, because running a big network in your machine is hard because you need a lot of resources. So if you have a cluster of Kubernetes, we can use Zombienet to launch your network there and running the tests against that network in Kubernetes, and that allows us to scale the network at your need. For example, I don't know, like we have some tests that are running like hundreds of nodes and like 50 parachain or something like that. And also we are working on Nomad provider that will open the door to not only use Zombienet locally or with container environment. We want to also use Zombienet to manage VMs or even bare metal servers. So our idea is that Zombienet can also be a tool for managed networks in the future, or long-lived networks, and that is our idea for the roadmap that we have for the next year. And another of the goals that we set when we start Zombienet is that we want a test runner built in Zombienet so people can easily write tests and should be extensible and flexible. So we build a DSL that is really intuitive. It's based on natural language. It's based on Cucumber language, customized by us. And we have this custom assertion that allow people to just run arbitrary code using Polkadot.js or code that run in the pods using whatever you want, it's scripting. And we also want that the same template language can be applied to the test feature or the test feature file that we have. So that was the 3 keys goal that we have when we start Zombienet. And one of the decisions that we take is that we have 2 different phases, and you can use, if you want, only the spawning phases or the test phase. Or even you can use the test if you pass all the configuration needed, and you can spawn the network manually if you want. So these 2 phases are not like tied in any way. So we have the spawn phase, is the way that Zombienet spawn the network for you. We take care of all the chain customization of the chain spec. We take care of create all the commands. If you are familiar with the CLI of Polkadot or the parachains, there's a lot of like arguments in there. So Zombienet take care of everything for you. We are also doing the port mapping for all the ports in the nodes, so you don't have to care about anything related to port mapping. And also we allow you to set, if you want to register a parachain, we can register for you even in the Genesis file, or we can register later if you want. So you can set the parachain, and we register the parachain in the relaychain automatically when we spawn the network. So that is like pretty easy for developers to just like run different scenarios with different parachains. And the second phase is the test phase. So we have this custom DSL that allow you to like express assertions in a natural language, and Zombienet, the test runner, will allow you to assert on the value that you expect, for example, the block height, or I don't know, like the peer counts, or we have different assertions that I will show you later. And I would say before, this test phase is extensible. You can write TypeScript or JavaScript file that we run for you in an embed environment that we just inject all the need that you need for your test, for example, the Polkadot.js key and all the information about the network. And we have a custom reporting, like produce a pretty nice reporting of the test running in a table, and we'll see later. So that's the phase, and related to how to use Zombienet, we have different options. You can use Zombienet as a binary. We create the binaries for macOS and for Linux in each release of Zombienet. You can grab them from GitHub releases. You can use also Zombienet as a library because we publish the modules in NPM. So it's available under the Zombienet scope, and you can use any of the models that we have there. If you want to use as a library, you will need the orchestrator. Is that the model that orchestrates everything for you? We have also the CLI as a model and the utils that has like different kind of utils you can maybe need if you want to create a custom version of something like that. We also publish an image in the Docker Hub that you can use. You can just use the Zombienet image. There is an entry point where you can pass the test that you want to run, and we'll run all the tests for you in this image. And if you want to contribute, or if you want to just see the source code, it's available on GitHub. You can transpile the code. It's a TypeScript, so you need to build it first, and you can run with any version of Node. So how do you download Zombienet? The idea is to make this a little bit with demos interactive. If you want to download with these few commands, you can download the binary for macOS and for Linux, and you need to make executable the file, right? So I don't know if you have any question. We can make question in the middle of presentation. It's okay, or we can continue. Yeah. Okay. No problem. So we build also a setup command, and most precisely Nikos build this command that allow people to easily start with Zombienet. So, but at the moment, this setup command works better with Linux because the binaries for Polkadot and the Polkadot parachain are not like released yet for macOS, but will be released in the future. So you can easily set like the setup, and you can say that you need a network with Polkadot and Polkadot parachain, and we download everything for you and start the network running, and just giving the information about how to export the path to the binary of Zombienet and start the network. As I said before, for macOS, it's not yet the same easily step for setup because we don't have the releases of Polkadot and Cumulus in macOS, but it's something that we already asked the different teams and will be released later. So the same setup command will work for macOS in the future. And for the moment, you need to download the repos, compile the binaries, and you can start using Zombienet. There is also a tool that we build, is a migration tool that allows you to migrate from Polkadot launch configuration to Zombienet configuration. It's really easy to convert this one. So you need to just point the Polkadot launch JSON file, and we convert the file to be a JSON that Zombienet recognizes and work with Zombienet. So if you are using Polkadot launch, migrate to Zombienet is super easy. You need just to run the convert script, and you can spawn your network with Zombienet. There is an examples here that I will show. This is the code for the examples. If you want to download, or if you want to take a picture and download later, it's here. So this was a nice presentation, but let's see in action, right? Let's spawn some networks. But first, how many of you spawn a network with parachains manually? And how was the experience? Slow, and do you have some errors? Do you remember to fuck up some time and say, oh, I have to start again? Something like that. Yeah, because one of the friction that we resolve with Zombienet is like launching a network manually has different steps that you can, is like very error prone. You need to create the chain spec, for example, for the parachain. You need to create the chain spec for the relay chain. If you are not using the developer's account, you need to inject the keys for each node. So you need to inject the keys in each node that you want to run. You need to start all the nodes from the relay chain using, this is like a very little example, but there could be several more arguments here. And you need to start the collector that has several other arguments, and then you can start registering your parachain. You need to register the parachain manually. So as you can see, there are a lot of steps. And Yeah, you need to wait to the parachain to be registered to start. Yeah, there is a lot of like steps, and everything in there is error prone. If you just like forget what command, or even if you need to make the port management, if you want to run locally, you need to set up the port for each node locally, and you can just like back up with the port management. You need to handle multiple processes and see that all the processes are living. For example, you need multiple commands. It's not like you are copy paste. You need to replace things, and it's super hard, and it's like a not trivial task, right? So Zombienet allows you to make everything that we see before in just one file. You declare the topology you want in your network, and Zombienet just spawn the network for you. So for example, a small network with a parachain and two relay chain nodes can be expressed this way in a TOML file. As you can see, we have like configuration for the relay chain. We have all these default things that you can configure, and all the nodes will inherit from the default configuration. And in here we run a Rococo local network, and we only need the names for the nodes, because by default the nodes of the relay chain are validators. If you want to not be a validator, you can set it's not a validator with validator equal false. We want a parachain register here, and we only step the command that Polkadot parachain is the command of this image. And with this, we can just run Zombienet and get this network with two relay chain nodes and one parachain register automatically. So let me just show that in action. So let's run this native. We'll run in my local machine. And the command is spawn. And in here is the first example. So it will start working. It will start creating. I can scroll a little bit. So just to show you. It doesn't scroll. What? I lose it scroll. Yeah. It's not there. Why? Scrolling is not good right now. But okay, I can scroll later. So right now it's already launched the relay chain nodes. As you can see, the command is like pretty big. And when the network is already ready, you see this like nice message about the network with the provided native, information about the relay chain nodes with like several links, direct link for using Polkadot.js to the Explorer, and for the metrics exposed by Prometheus, and a link for the collator and the chain spec. So if you just go to the here, let me just make this bigger. Okay. The network is running. You can see it's producing blocks, and the parachain should be registered here. And yeah, it's already registered. It's producing blocks. So with this one command, one file with like dozen of lines, you can have a network already working. And all the chain spec configuration, all the key management, all the port management, all the information is handled by Zombienet. And if you just removing everything, when you stop your exploration about this network, you just stop the Zombienet process, and we remove everything for you. So we remove the process, we just keep the files in a temporary directory, so it will be clean when you restart your machine. Let me show you if I can scroll here. Okay, let's scroll over there. Okay, let's back to the presentation. Close this, it's not running anymore, and So with these few lines, we get the network that if we want to launch manually, we have like doing several steps and takes time, is error prone, and yeah, it's like a hard task to do it. As I said before, we have like this nice output of the network that we are running, and this is here we just show the command that we run. The provider argument is, we will see later, we have a few options, and the command is spawn or test for your network. And related to how we spawn the network, we have different options. We say that we want to scale the network, we want to be flexible, so we can run also like node groups, and you can expect how many of these nodes you want. This is great when you want, for example, create scenarios with different binaries running in nodes. You can have like different groups running different binaries, or even different groups running different commands or with different arguments if you want. So you can run that. You can run several parachains if you want. And we can see also this example running locally. Let me show you. So in this case, we will create a network with more nodes, with 5 nodes, and in a group and different parachains. As you can see, the parachain in here are added in the genesis, but if you say that you don't want, there is a configuration that you can set in the TOML file to register your parachain after the network is launched automatically, so you don't have the parachain in your genesis file. Let's wait to see this running. We are running, I think, 5 validators in a group here, and then the collator for the parachain. In this case, we are running a state mine parachain and another like default parachain. And if you go here to Explorer again, you see that it's already producing blocks. And if you go to the parachain, we have 2 parachains registered waiting the first epoch to produce blocks. And in this case, the network information is bigger because of the nodes. And our information here is that when you're running locally, we just output the logs to a file, so you can see the logs in action in your machine, just tailing that file. Each node is containing one directory, so you can see all the artifacts that the node use. For example, the key store, the database, everything for the nodes we isolate in each directory for nodes. So you can see the logs, the artifacts, the database, you can see there. Let's just see if the parachain is not producing logs yet, but should be in a moment. What? The base path? Yeah. Right now it's producing blocks. Yeah. So yeah, you can change. So by default, we use a base path in your temporary directory of your operating system, because the idea is that it's like ephemeral network, so you can remove when you restart your machine, or you can remove manually. But if you want to keep around your files, your database, your key store, everything, you can use we have a directory argument that you can pass, and you pass a directory, and we use that as a base path for create everything. And if you pass the same directory that it was from the previous run of the network, we start the same network, so you don't lose any state. So, sorry? The ports, as you say, that we pick up randomly, but you can specify the port. if you want to be sure that it will run with that port, you can specify in, for example, let me go again to the presentation. And in here, for node groups, you cannot do that because they are not groups. But if you specify individual nodes, you can specify for example, the port to use, the WebSocket port. So they're all configuration that you can set. But by default, Zombienet, the idea is that by default, you don't have to set everything. You set only what thing you know that you need. For example, you need to manage the port and you want to do it, you can do it. You can do also, you can manage the log file, you can manage all the stuff, but by default we manage for you. But we open the door that if you need and you know what you need, you can do it. So, okay. Another example here is, as I said before, we can, this concept of group, for example, in here is like an example of running 2 node groups, right? With 5 nodes each group. And in this case, for example, it's just an example. We can have like different arguments for the node groups, and this group will debug all the parachain information, and the other group is not debugging information, but it uses another version. As I said before, this, for example, if you use Postman or Kubernetes, this will have the master version of Polkadot or the master image for Polkadot, and this group will have 5 nodes with another version. In this case, it's 930, but the idea is that you can manage to have different groups with different versions of the image or of the binary that you want to run. And other thing that we have is, we talked several times about the templating language that we have for the configuration file and for the testing file. So the templating language that we use is Nunchucks, because at the moment, Zombienet is writing TypeScript, and Nunchuck is very similar to Terra. I don't know if you are familiar with Terra. It's like a templating language for Rust. It's like handlebars or something like that. So you can define variables with these like curly braces, 2 curly braces, and we replace them for you from your environment variables. So this is great, for example, to use Zombienet in CI when you don't want to run the same image or the hard-coded image, and you can set up your environment to run the image that you are building. That is the way that we use internally. For each PR, we build an image with that PR, and we set the environment to run that particular version of Polkadot. And to make dynamic, as I said before, Zombienet is just grabbing the network definition and see all the environment variables that you have, replace everything in there, and is launching your network with that information. So I think I have also here an example. Let me show you first. I think it's 4. Yeah. Zooming? Yeah. So in here we define this Zombienet integration test image to run all the nodes, and that will be picked up from my environment. Let me just running this, and yeah. So in this case, we don't passing any provider. So the default provider is Kubernetes. We can pass if you want, but if you don't pass with the default, it will always be Kubernetes. In this case, as we want to run different image, I need to use Kubernetes. It will be like a little bit slow than native because it's running in a cluster of Kubernetes that we have. But the idea is that you can, from your environment, set up the things that you want to run with Zombienet, so you can have like your Zombienet configuration or your network configuration, your test configuration, like dynamically set by your environment. And again, this is the same. So as creating the chain spec, customizing the chain spec with the keys that we need. In this case, we use Alice and Bob, but could be another ones if you want. And once we get, once we get the chain spec in a raw format, we start all the nodes. In this case, I don't set, but you can specify the concurrency for launching the node. If you want to launch one by one, it's the default. If you specify another concurrency, we can spawn the nodes in batch, for example, now like 20 or 10 or what you want. And in this case, it's running in our cluster. So yeah, it will take a little bit longer to be ready in the network. Yeah, okay. Same network, but in this case, running a Kubernetes cluster. Okay, just continue here. Okay, this is just an example that we see about how we launch the in-admin network. We can grab, so you can set the environment in different ways. These are just examples. You can use like a prefix in the command. You can export the variable that you need like this, and you can also have like an environment file that you can source from there. And in these two, you keep the environment set in your terminal. In the first one, not. So you can lose, and you need to, every time that you run Zombienet, you need the prefix, the variable that will run the command. That is like, and as a note, this is only for Kubernetes or Podman provider, because this is image, and in native it doesn't make sense to set the image. And we talked several times about providers. So what are providers for Zombienet? At this moment, we have 3 providers. The main provider is Kubernetes because it's the provider that we use in our internal CI. So it's the provider that has more features. So Zombienet is integrated right now with the Grafana stack that we have internally. And with Kubernetes, if you have a Grafana stack, it's pretty easy to integrate, and you will see all the benefits to be integrated with that. For example, you have the metrics in a Grafana dashboard, logs using Loki, or even span traces using Tempo. So we have all the features set for Kubernetes. But if you want to use Podman locally, we also have all these features spawning for you. When you spawn a network with Podman, you will see that we spawn for you some kind of Grafana stack using Prometheus, Grafana, and Tempo, and wire everything you can see in a dashboard, for example, see the metrics in Prometheus, or even the spawns using the Jagger. And with native, we just spawn the process. So we don't have like other infrastructure in native, but it's something that we are thinking about. See if we can set up something for the native provider also to see, for example, the logs in Grafana or something like that. It's an experimentation that we think we can do it in the next year. Let me show you how it looks this in Podman. Okay. So let me launch this in Podman. So as you can see, one of the first things that Zombienet does when you run with Podman is start all the infrastructure stack we need, for example, Prometheus, Tempo, and Grafana, and give you links to direct access, so you can access to Grafana. And it's a fresh installation of Grafana, so will be like admin access, because it's like just an image of Grafana that will run for you, and when you stop your Zombienet environment, will just remove everything. So it will be something like admin. It's the default installation, right? Let me just remove this. Okay, yeah, okay. Okay, yeah. So you can have your Grafana default, and we wire everything to just, you can use that Grafana to see, for example, the metrics and stuff like that for this particular network that we are launching here with Zombienet. And when we just remove the network or just stop the network, we remove everything. And every time you start with a fresh Grafana stack. What? Oh, sorry. So let's wait a little bit. Uh, so in this case, for see the logs, we also like showing helps how to see the logs of the pod itself with a command. This will finish in a moment. Okay, it's already running, and you can also go here and see the network in action. It's already producing logs, and the parachain is also working. So as you can see, with the same file, we launched the network in 3 different environments, locally, in Kubernetes, and in Podman, without changing anything. It's just changing the provider and using the Zombienet to manage those environments. Again, the Podman infrastructure that we have at the moment is this free, like Prometheus, Tempo, and Grafana image or pod that we run for you. And we have like this nice message at the beginning of the network to access them. Okay, so here is the part that if you want, you can run from native to Kubernetes. Is some of the things that I already show you. And I don't know if you, was me? No, okay. If you want to run this, or if you have questions related to how to run Zombienet in, for example, these 3 providers that we have. So the idea is just to, again, show that with the same file, with the same configuration, you don't have to change anything. You can run natively, you can run in Podman, and you can run in a Kubernetes cluster if you want. So we can move forward if you don't want to try this or have questions related to this. Yeah. Yeah. So the question is that given is the same file, how Zombienet determines which is the binary that you need to run. Okay, yeah. So we have 2 configurations that manage how Zombienet works. The image that is only used for broadband and Kubernetes provider, and the command. If you see, there is an image and command. We have the default command that you can set, and all the nodes will run the same command. So if you are running natively, the command will just run that binary, and will match the same binary in the image if you have like an image for your repository. So, make sense? Yeah, great.
The questions? We have this nice catch box. If somebody has a question, I'm going to throw it and you can talk to it.
Yeah, my question is regarding setting up like with the custom parachain. When you want to set up with a custom parachain, like how do you initially register the genesis state with the relaychain in this framework?
Yeah. So the question was, how is the registering parachain in this framework? We have two options, as I said before. The default option is just create the WASM and the state for your custom parachain, and we set up that in the Genesis file. We include the WASM and the state in the Genesis in the parachain, like part of the Genesis configuration of the relay chain. So automatically, when we start the network, your parachain is registered, right? But if you don't want to do that and you want to go through the registering process of the site, you can do it also. You can set up that you want to register your parachain, but not in the Genesis file. It's a configuration I can show you later. And in that case, Zombienet will start the relay chain and just we produce the artifact, the state, and the WASM for you, and just run a JavaScript file to register your parachain if you want. And you can also set that you don't want to register your parachain, for example. Zombienet will run, we will produce your state and WASM in the directory for your parachain collator, and then if you want to register manually, you can do it. So you have the network running and you have all the files to register. So there is like that three options to do it. But the default option is register your parachain and in the Genesis file. That is it.
One small thing, like you can still set the Genesis chain spec for the parachain independently, right? Like for your custom parachain, you can set up the chain spec independently, right? For the Zombienet framework. Like
yeah, so Zombienet will create the chain spec for your parachain. One of these
you
steps.
Cannot set like a custom.
Yeah, you can set. You can specify a path to a JSON file. You have two options. You can set the command to create your chain spec for your parachain. So we'll run the command that you set, and we create the parachain. And the other option is that you can just set the path of your JSON file of the parachain chain spec, and we use that file. And if you use that file and it's in the plain format of the file, we can customize, for example, the keys. But if you set in raw format, we just use your file. So in that case, you need to match the keys in the node, right? But if you set in plain, we can customize the keys. That's okay? Yeah.
Hello. Our chain, our team has attempted to use Zombienet a while before, like maybe half a year ago, and we had trouble setting it up. Suppose it was like lack of something universal. And my question was, maybe I'm too late to the presentation, but still, has Zombienet, how well has Zombienet evolved, like in the last half a year?
Okay. Yeah. I don't know what are the problems that you have. Which network is?
Unique network.
Unique network. I remember some GitHub issues about that. Yeah. Yeah. So in the last few months, we evolved and we just create a system that we call the registry system of the decorator system that allow parachains to be customized the behavior of Zombienet to allow more like custom behavior for each parachain. So that is the design that we have for the future, is that Zombienet will have a default behavior that we need internally. So it's the behavior that we test for Polkadot every day, but we open the door for customization or decoration the behavior of Zombienet for each parachain. So I think Unique is already working with Zombienet. If I don't,
No, we're not working with Zombienet just yet, but we're surely considering the change once it is, so to speak, cooked through.
yeah,
Sorry.
okay, yeah, because this decorator pattern is we just released like 2 months ago or something like that. Free.
Good.
1 month ago, yeah, 1 month ago. We
Yeah,
have
that's
different
wonderful.
parachains already working. I think it's Moonbeam, Akala, Bifrost, Oak, and yeah, we have several. And the idea is that we see the friction for the parachains because they need like custom behavior, mostly in the chain aspect and in the command that they need to run. So we open the door with this decorator pattern that they can like create pull requests to Zombienet, and we add to this system. So we match the network that you are running, and we like decorate all the behavior related to your parachain for running with Zombienet.
Thank you.
Yeah, you're welcome.
Hello. Hi.
Hi.
One of the most common use cases for spinning up such a heavy network like this, as opposed to just running a dev node, is that you're trying to verify a runtime upgrade against production state. Is there any intention for Zombienet to do, because I mean pretty much every chain upgrades its runtime the same way. You import the state, you make that in your Genesis block, you change the keys for the governance, and then you do a set code, and then I mean pretty much every chain upgrades the runtime the same way. Do you think that Zombienet will ever be able to make that easier for us? Or would you say that's not really what you guys are trying to do?
Yeah, definitely. We are working on that for the new version. We have some like runtime upgrade assertions right now, so you can upgrade your network with Zombienet. But also we have like a feature that is not well documented right now that you can start your network from a snapshot right now. But in the future, that is the idea, is not only have the upgrade for the network, just it's also like a fork off the network.
Yeah, exactly.
For a live network, just fork off the network and then customize everything that you can run the upgrade for that from the state that you fork off for the live network.
Perfect,
That
thanks.
yeah, it's something that is in the V2 roadmap that we have for the next year. So right now you need to launch your network from this state with the snapshot, and you can upgrade. But in the future, it will be more easy to do.
Perfect, thank you.
Yeah, you're welcome. Yeah. Oh.
What you said was, does this mean that you can fork real network, for example, Kusama, and run something on top of, for example, block X, just to see what will happen?
Yeah, that is our goal. So that doesn't work right now, but it's our goal for the next version. That you can specify which network, which light network you want to fork off, and fork off the network, customize everything, replace keys and everything, and start like building the network there, and you have all the keys from your validator are running through Zombienet. But it's in the roadmap. It's not. I cannot show you nothing. Yeah.
That's very cool.
Yeah. Thanks.
Can you hear me? Okay. So I don't know if this feature is already supported, but is there the option or the plan to basically add the testing feature, the DSCL, basically where we can call extrinsics and get also the storage, query the storage, into the setup, the spawn. When we are spawning the network, if part of our setup is calling an extrinsic, is that supported, or are there already plans for supporting it?
Okay, so when you spawn the network, you need to get information.
Yeah, for example, after spawning all the parchains, on statement I want to, let's say, create 2 tokens, mint some tokens, and then do a reverse transfer to other parachain. Is it possible to include it as a script in the spawn part? So, like we do in testing, I think we can call extrinsics on the test. So, doing that on the spawn, when we are after spawning the parachains, let's say, I think it is part of the setup of our environment.
So I think we can do it. We need to change some things because like the decorator system that we have in place allow you to run arbitrary code that you set up, but you don't have the network information injected there. In your case, you will need the network information injected there to know the endpoints to get the information of the different parachain of the relay chain. But we can do it. It's something like we run the function that you decorate in different entry points of building your parachain and launching the parachain. So it's one step we can include the information and allow you to run like your code to get
I think
information.
it will be useful for developing to save some time, setting everything and configuring the environment will be a good feature to have.
Yeah, definitely. And also, as I said before, you can set the base path or the directory or a snapshot, and we can run from that directory or a snapshot that we grab from the internet and spawn the network from there, and you can have this.
Configured.
Yeah, you can have all the setup done. For example, I don't know if you were in the Hector talk yesterday about Trappist.
I was not.
Okay, he needs to set up different things to show in the parachain asset, stuff like that, and we build that feature for that example that they have. That's the idea. I don't want to set up everything each time that I run Zombienet.
Saves a lot
I
of
want
time.
to have like a snapshot from here and start everything from here every time that I start.
Yeah.
So we build that, yeah. But we can also add the feature that you need.
I just wanted to ask about the feasibility of a tool like Zombienet for testing different consensus mechanisms, such as end-to-end testing of Grandpa or alternative designs.
Yeah, at the moment we don't have like that in the roadmap. So Zombienet creates some kind of like the binaries like a black box. We just run. We don't like interact with the consensus. So you can test some of the things of the consensus if the nodes expose metrics, for example. We have that in Polkadot internally. So we just see like block production, we see like different stuff there. And we have some integration, for example, with Polkadot introspector that allow you to get more information about the nodes. So you can do it, but it's not something that is Zombienet managed to do it. You need to run a node or run a binary that expose that information through Prometheus to use Zombienet to query the metrics.
Sure. And then with Zombienet, could you kill a node at some arbitrary point and restart it later?
Yeah.
All right.
You can do that. You can pause the process, for example, if you want. Like we have tested that we need to pause the process and start like 10 seconds or 20 seconds later and see how is the syncing process. And yeah, another feature that we want to add is like start nodes from the test definition. Right now, all the nodes start in the spawning phase, and you can stop them or restart them in the test definition, but you cannot start a new node from the beginning. In the new version, you will. The idea is to create an SDK that allow you to express these complex scenarios where you have a live network and you want to add a new node in the middle of the running, for example. Yeah.
Thank you.
Yeah, you're welcome.
With the snapshots, do you have any problems if they're like stale and old, and then when the nodes come up, there'll be like an invalid validator epoch because it thinks it's like could be like a month in the future and the election isn't valid anymore? Have you run into the issue?
Yeah, in that case, the network could be stale. From Zombienet point of view, the node is running. We care about the running process. The running network is more like related to the person that is running the experiment of the test, and should be a valid example that I know that is I should say stale and the network just break. How you manage to fix them is like out of the scope of Zombienet, right? But could be an example, like if I broke the network and this place, how I fix it.
Right. Yeah. Yeah. Because I've used libfaketime to like
Yeah,
restore
it's-
the old ones
Yeah, yeah,
with the
it's-
LD
yeah, yeah.
preload. But yeah. Thank you.
You're welcome.
Just to mention something about the consensus part, if you use Podman as a provider, there are chaos engineering tools, for example, Pumba, which you can use to simulate network degradation between the pods and things like this. So for his case, you can do it like this. It's a bit manual, but you can do the job done.
Okay. Yeah, we have the plan for the roadmap for the next year. We want to introduce like chaos testing concept in Zombienet that allow you to make these things. Our goal first is to do it with Kubernetes, with a chaos mesh like a Helm chart. But the idea is, as I said before, our main provider is Kubernetes, but the idea is that we go and once we have Kubernetes support something, we try to all the providers support the same kind of features. With Podman, we can use those tools. With native, we need to just make tools with like I don't know, like IP tables or stuff like that. Yeah, but the idea is to have the same set of features in all the providers. Yeah. Yeah.
Is there any support for stuff like an indexer as well, or is that out of scope and I would have to stand it up myself? Like if I have a subquery instance trying to index the node events and I want to test that?
Yeah, but so the indexer should be available at some place. So we run only the nodes for the network, right?
Yeah, makes sense.
Yeah, we have an idea to allow users to run companions. So you can run an image or a process that you want to run and connect them. So in this case, you can spawn a network and spawn a companion with an indexer, and you can query the indexer from the DSL or from your
Right.
script.
Yeah, it makes sense. That's what I was thinking.
But automatically, we don't run any indexer.
Right.
Yeah.
Or otherwise it can be like a new
Yeah, it will be
command
like-
to stand up. Yeah.
yeah.
All right.
Okay, so continue with these presentations. Yeah, I will show yeah. So now we've gone through the spawning phase, and in this case we start talking about the test runner. As I said before, one of the goals of Zombienet is like not only spawn networks, but also provide a framework to test or make assertions through that network. So we build this test runner that allow users to simply use a DSL to easily and intuitive write testing. It's some kind of Cucumber natural language mix that we have is using a grammar parser. And the idea is you don't have to you can write assertion very easy and everyone can assert on block height or stuff like that for a network. You don't need to write complex script or something like that to make a test. And I talked before about the assertion that we have, and the built-in assertion that we have at the moment are these 5 categories that we have. The first is that we expose all the metrics from the nodes using Prometheus. So we can assert in any metrics that is exposed there and any histogram that is exposed there. For example, a histogram, you can say if a value is in different buckets or something like that, or metrics can be equal or less or bigger if you want. We have chain events that you can subscribe. You can subscribe event from the live network. And also you can query the storage for getting information. We can run custom scripts. As I said before, if you run JavaScript files, we can run from the test runner, injecting all the information about the network. And also you can run bash or other kind of binaries or a script that you want inside of the pods. If you're using Kubernetes of Podman, and if you use native, it's we just change the directory to the directory of the node, so if you have relative paths, it will work also there. We can read and match the logs from the nodes for different. You can use regex or glob, matching patterns. And as I said before, we have different kind of integrations. At the moment, we integrate with the Polkadot introspector, with the Jagger spans that the nodes produce, and we have a back channel integration. The back channel is something that is also built in the Polkadot node and create an start mesh that forward the message. And the idea is that the nodes from Polkadot that use the back channel can communicate with the test runner. So you can, for example, coordinate an attack or something like that. So the test runner and all the nodes, so the test runner will forward all the information to all the nodes, and all the nodes will have the same information. The back channel is something that we build internally, and you need like the version that we have from Polkadot to use it. A little bit more information about the assertion, just to have a sentence of everyone. Query using Prometheus. All the chain assertion is made through Polkadot.js. The custom scripts, again, the logs can use regex or globs matching patterns, and the integration that I said before, for example, the back channel and the introspector. So, example of the DSL. The first 3 lines that you can see here are we call the header of the DSL. That you have the description that we show in the test report. You can point the network file you need to run, because when you run the test, we just grab the information of the topology of the network from there. And the credential is only used for Kubernetes. It's in there. And if you don't put anything, we use the default. That is if you have like different Kubernetes cluster and you don't use context and you use only files, you can specify the file to use as a configuration for the credentials of your Kubernetes cluster. Then each line is an assertion, so you define each line an assertion, and that is running sequentially. So in this case, for example, we assert that the validator group is up, and this will check all the nodes in the validator group, and you can specify also the individual nodes in the group. For example, we use the validator 0 to see if the parachain 100 is registered, and we use this between keyword to specify some kind of timeout. Is the time that we keep trying to get the value for you. So if the parachain 100 is registered before this time, we acknowledge that the test is okay, but after 225 seconds, we just set like a timeout and we say that the test failed, for example. Here is an example of using metrics with the keyword reports. So you always need to specify or a group or a node in particular. For the metrics, we need to go, in this case, to one validator because we want to retrieve the information from only one node, and we want to ensure that the role of the node is 4. In this case, is that running as a validator. And also, we assert on the block height of the network that should be at least 2 after or between 15 seconds. An example of how do we match the logs of the validators. We can use the glob pattern here, and by default we use a regex. So if you don't say the log line match with the glob pattern, you use regex. The same with the system event. If you want to match on events of the network, you can say that contains, and we use as a regex. And if you say match glob, we use as a glob pattern. And the last examples are running JavaScript files or files script inside the pods, and you can specify like the relative path to the JavaScript file that we need to embed and run in the test runner, and you can send arguments in some kind of list here. You can it's comma separate list for arguments, and also we can assert on the return value of the script that you want to run. I think I have one example here related to this. Let me show you. So we use these Zombienet DSL files, but we are not like having a match in there. If you use other extension, we run the test for you. So the first thing when we run the test is starting the network for you. And in this case, I think we can see also what are the tests here. I will just, yeah. I know. So in this case, we have several assertions about the validator group is up, and I think it's like pretty the same. Yeah. Okay, it's not here. So the network is already running, so we'll start running the test. First, see if all the validator is up, and if the parachain is registered. The second parachain the same. Then we have the metrics that we have to wait a little bit for have the height that we need. Oh, yeah. Yeah, you can see the time that consuming for each of the assertion that we run. And you can see also the network running here. And there's no events yet. Yeah. This should work after a while. Yeah, we can combine later. Yeah, it's okay. Let me see if the parachain are, yeah, we can combine later. So we build this DSL and we find that learning a new templated language or DSL language is not like quite nice. So we build an extension that helps everyone to write file using our DSL. This is like a picture of the repository that we have and how to set up the extension for VS Code. So that will help you to write, like, let me show you. If I have here, oh. It is, where is this? Yeah. If you want to go here and, for example, say reports or restart, we have all these extensions that allow you to write easily tests. For example, if you want to assert on a metric, you can just, if you have the extension installed, you can say report, and it will generate all the fields you can complete, like Alice and what is like everything. And for example, resume or something like that, you have all the information also. So it's easily to write tests, and it's more easily to write tests with the DSL. It's super easy to write different tests. Yeah, sorry.
Is this a VS Code extension only, or does it support LSP to use in any other editor?
At the moment, it's only VS Code. Yeah.
Is there plans to make it LSP? Because like I don't use VS Code personally, but it'd be very handy to use outside of VS Code.
Yeah. So it's not in the roadmap. It's something that we can do it. We don't have like. I will see if we'll see that in the future we have a DSL idea. An SDK idea. So the DSL will maintain, but we don't grow in the DSL. We want to just use the DSL for the basic stuff, and for complex scenarios or tests, we want to build as SDK. But yeah, if you need for other like system that is not VS Code, we can ask as a feature request, and we can do it. If you want, I can open an issue in GitHub to follow that. It's okay.
Yeah, I mean,
yeah.
I will if you don't. So.
Yeah, no problem.
You
Yeah.
can actually add a GitHub request, and you can see how it's for us to implement this project.
Yeah, it should be pretty easy to port the snippet that we have for VS Code to other systems. So yeah. So as we see before, the command for running the test is test, and allow you to set the provider also, and we have this like information about the test and the reporting. When all the tests are green, you see this nice reporting about everything, about the timing that consume each assertion, the timing that we start assertion, the result, and the exit code. In this case, it's 0 because we don't have any like fail assertion. And we clean the network, right? And we talked that we want to Zombienet be extensible, so we want to allow users to run like this custom JS assertion and extend the test that we have, because we don't want to be like the bottleneck that we need to write an assertion for every test that people needs. So in this case, as I said before, we have this JS script assertion that allow you to run a function that you expose in a different file. Your file needs to expose this run function, and the run function receives different arguments. The first argument is the node that needs to connect, or the node that you set in the assertion line to run the test. All the network information that contains the Prometheus endpoint, the endpoint for the node, and all the running network information. And also the argument that you pass to the for width, we transform in an array of arguments that you can get there. And other thing that we made in this like custom JS script is that we inject the zombie object with different things. For example, the connect function to connect to a node, the API promise from Polkadot.js, or the keyring. And it's pretty the same. I don't know if you are familiar with the developer tab in the Polkadot.js portal. If you go to the developer, if you want to write something there, it's in a closure that it has already like things injected. We use the same pattern. We inject all the things, the keyring, the API promise, anything in there, and we run your function inside this closure. So I think it's here. Let me show you. Yeah. Shut down all the network. Yeah. Okay. I think if we go here, we need to go to a live network, right? For example, Kusama. Yeah. So it's the same that from here. You run the function that we run the function that you expose inside the kind of like closure, injecting all the zombie object with all this API hashing and everything there. But we want users to have more power and more extensibility to Zombienet too. So it's nice to have Zombienet like using in a way that we use, but we want to allow users to use as a library and build on top of Zombienet. We don't want to be like, as I said before, the bottleneck that we need to write everything for every team. So we allow teams to use Zombienet as a library, for example, using the orchestrated module that exposes the start function as an entry point. So in this case, you see that we are using the modules and we import the network configuration for reading from the utils. And it's the same that we run this network that we have here. It's the same file that I showed you before, the small network. And we can launch as a library from here using the start, and we receive all the information in the network. So you can build your own like test framework, your own spawning framework if you want, using Zombienet, and you can build on top of that. Let me show you how it's, oh, this is finished. If you want to here's library, and I have a little example here. It's the same as I showed before. You can see we are running the same example there. If we want to run here, we will see that using the same orchestrator, you get the same output and you get all the network information, but it's in a way that you can build on top of that. If you don't want to build some other like functionalities or some other feature that you need for your test or for spawning your network in particular, you can use Zombienet as a library, and we expose, oh, yeah, something failed here. Can happen. Oh, okay. So, yeah. And also related to extensibility, we want to Zombienet also be more friendly for the different team and have more extensibility. So we build the parachain, so the chain spec customization, and we build this decorate pattern behavior. So we allow users to decorate or customize the behavior of Zombienet and how it's managed. And for that, we build this kind of registry that each parachain can be included with a PR to the Zombienet repo. At the moment, we have these parachains, and each parachain will be like import and customize function that we have. And when we detect that is a parachain that is running, we just decorate all the functions that we use for customize the chain spec. So from the parachain team vision in particular, they need to just decorate one of these functions, for example, that for adding the authority or clear the authority, or for example, the node keys is one of the that most of the team using. And when they have including in the registry, they can allow teams to interact very easily with Zombienet. So you can use Zombienet to expand our network with your parachain and other parachain like Moonbeam, Nakala, and stuff like that. Yeah. What? Okay. So let me show. So in here, for register a parachain, I will show you a little bit of code here. Let me just go here and let's take one example of Akala, and just in this case, Akala just only decorate this function, but we have other teams that decorate more functions. For example, the Moonbeam, I don't know, is decorate different functions here. And the idea is that each parachain has like custom needs in the chain spec that from the Zombienet point of view, we cannot like handle everything from Zombienet. So we allow different teams to contribute with the Zombienet base code and contribute with the decorator or the registry that we have, and make useful for everyone, because once they are here, you can from your team use one of these parachain and we know that will run okay and we customize the chain spec as they need. So for creating this parachain register, you need to just open a PR and just decorate one of the function that we have, and then you need to add here as a para, and we have this like interface you need to implement, and then we create like the decorator. So the process is super simple. We don't have time right now to create a new parachain and register in the registry, but we can see if someone has question about this, we can see later. So that is what Zombienet does at the moment, currently, and this is the road that we have ahead for the development of the V2. You can see the roadmap in GitHub. We have a public roadmap of the V2, but the main goals is introduce this chaos testing framework, add more providers. In particular, Nomad is one we are working right now, and we also want to add Docker because Postman is great, but we receive feedback from people that they want to use Docker. We want to create this SDK that allow people to interact with the complex scenarios without the DSL, without the network topology file. So they just want to like build a network from code and run the network in code and the test all in one file that you can run, for example, with TypeScript or Rust. Our goal is to support both TypeScript and Rust from the SDK. And other goal that we have for the future is to Zombienet can manage long-lived networks and not only ephemeral. So you can use Zombienet as a like deployment tool for your network. And just closing this presentation, some acknowledge and contribution is like, as I said before, Zombienet takes several patterns and inspiration for particular these two projects, the Polkadot Launch and SimNet. And if you have feedback and you want to contribute to the project, this is the GitHub repository, and we always open to listen feature requests, bugs reporting, and feedback from the community. So I don't know if you have more questions. This is like a roadmap of all the presentation, just like in a view all the presentation. I don't know if you have
any questions?
Any questions?
No questions.
No, there are questions.
With the custom test things, would I be able to use Jest to do the assertions? Like if I'm do I have to use the DSL to do the test assertions, or could I use Jest if I wanted with a custom JS runner?
So you can use custom JS assertion to run an arbitrary JS file inside our test runner. But you can use Zombienet as a library, as I showed as a library, and you can just run your own test framework if you want. So basically you can use Zombienet for spawning the network, and you receive all the information and run your test. And the orchestrator module also expose a test function that you can spawn the network and write your test there in a closure. So you get the information and we run the function closure with the network information injected. So you can, if you want, you cannot use the DSL and create your test.
Right. Makes sense. Yeah. Like there's the flexibility.
Yeah.
What's the best way to stay up to date with the capabilities of Zombienet in terms of syntax, like to know what you can do with the tool, like documentation, reference, something like this?
Yeah, the question was, where is the documentation about Zombienet and the capabilities that they have at the moment? So the documentation is in the repo of Zombienet, if you go, and there is a link to an MD book about the documentation. So let me just go here. So you have, we try to be updated here, and in general the network definition for everything is in this place. So in here you see all the options that you have for settings, for the relaychain nodes and stuff like this. Yeah, you can have here all the information about parachain, how to register. For example, if you don't want to add to Genesis your parachain, you can set add to parachain false, add to Genesis, sorry, false. And all this information are the network definition file. And we have also like documentation about the DSL here and how to use everything, and the feature that we provide for each of the providers. So this is pretty up to date. It could be something that is missing, but we try to keep updated. Yeah.